In this video, we're going to start doing some of our various hypothesis test methods in R. So let's, again, we can read in our student survey data set so that we have the data we want to look at. Now let's start first and foremost with tests for proportions. So the function that we can use for proportions is prop.test. Now, with prop.test, similar to pie charts and bar plot functions, we need to pass in counts. Now, the most common way of doing this is to pass in, once again, a table value. However, that can be a little confusing because R is going to take values in a table, and it's going to start assuming you want to do everything according to alphabetical order. All right. So, say that we're interested in our categorical variables in here. Perhaps I want to know about smoking status. Now, if I come in and do prop.test and I pass in table, student survey, sub smoke. Now, this is one of the first arguments. We also need to specify, if we're doing just one proportion, what our null proportion is. So perhaps I think, okay, I think that the proportion is just 10%. And I want to test that. I'm going to leave alternative alone, and if you leave it alone, it's going to assume two-sided, and you can choose to update this correct or not. This is just a small sample size correction that R can do. Probably not terribly necessary for our data set, but you can consider it for smaller data sets. Now, if I run this, I'm going to get some interesting values. One, notice that it estimates my proportion. Say my proportion is almost 90%. What happens when I actually look at this table value? So if I run table, I see I've got 319 that said no smoking and 43 that said yes. That's definitely not almost 90%. That's closer to that 10% we were hypothesizing. So what's happened here? R is taking the earlier alphabetical order value and is modeling that. So it's going to model no rather than yes. It doesn't know for sure what value you want, and so it's always going to assume alphabetical order. So you can do this with a table function, and you have to be aware of that. You have to be careful of it. A way to fix this, well, you could just model no instead of yes, and so in the end you're going to get the test that you wanted. So instead of modeling 10% as yes, I'm going to model 90% as no. If I do this, then I can run it again. I still get that same proportion, but now you'll notice my p-value, my x-squared value, which is just the z-score value you'd get squared, these have all changed. Now with proportion test, if you are worried about that and you specifically want to model a certain value, you can use this x and n input instead, where x is going to be the number in the category I'm interested in. So for this case, it's going to be 43, and n is the total number. So not just 319, but 319 plus my 43. And then I can specify p equals 1 again. Now if I run this, note that, oh, now it's calculated the correct proportion, but we have the same value here for our p-value and our test statistic. So R has calculated the same values, it's just needing you to specify things a little bit more precisely. Now say that instead of just dealing with a yes-no type variable, I'm interested in one of these others. Say award. We looked at award before. I want to know, oh, is there a certain proportion that's equal to Olympic? Now, there's a little bit of a trick we can do here. We can pass in our table function again, but if I pass in student survey sub award and say that I say p is equal to 0.2. Now, if you run this, R is going to get mad at you. It's going to say, hey, you've got more than 2 levels. I should only have 2 levels. Or more specifically, this table has 3 levels. What are you doing? Well, to overcome this, you can either go in and once again say, oh, I'm interested in modeling Olympic. So I'm going to do x equals 182, n equals, add all the rest together, and then set your proportion. That's one method. Something else you can do, though, is add in here and say, I'm interested in the level of Olympic. Now what this item here is going to do is it's going to go through, and instead of now having Academy, Nobel, and Olympic, I'm going to get a bunch of true and falses. True is going to be indicative of Olympic, and false is everything else combined. And so if I run my prop.test on this, well, just as a note, we're going to have an issue again. If I run it just this way, what comes first alphabetically? It's going to be false. So we're not going to be modeling things the way we want to. So you can either account for that and adjust your null hypothesis as you need to, or the other option is to come in and change this to not equal to Olympic. Thus, when my table comes out, notice we just switched to true and false. So now everything that's false is Olympic and everything that's true is everything else. So it's a little bit of a trick, follow that carefully, but you can do that to run these tests if you have more than 2 levels. The final option that we may be interested in is running a test for comparing 2 groups. So perhaps I want to know, hey, let's take a look at this Olympic value again. I want to know if values are equal to Olympic or not, but I want to compare it against level of smoking status. And so we can pass in this 2-way table into this prop.test, and it's going to assume we want to test if the 2 proportions are equal, as we typically do. And note here, well, kind of looks like it from this, our Olympic medal and our smoking status, that maybe perhaps we do actually have somewhat of an even value. And so when we run this, we are going to find, oh, looks like we're modeling non-smoking again, but the proportion between, of subjects that want to win an Olympic medal or that don't smoke is the same between those that don't want to win an Olympic medal and those that do, or very, very close. And we see our corresponding p-value. So this is an easy way to pass in and do 2 proportion z-tests.